Hello students, this video is designed to help review the Regents questions on triangles. You should be watching this video right before you take the post-test on triangles, right at the end of the year before you take that test. Obviously you should have tried the questions that are in the packet, and then you should unpause the video and see if you got them right. So do that now. Alright, let's take a look at the answers here. For the first question, it asks how long is QP, and it gives us some measurements. In this problem, we have two similar triangles, and these similar triangles are proportional. So that means we're going to set up a proportion of small over large equals small over large. One side of one small triangle to the same or the corresponding side of the larger triangle is equal to two corresponding sides of the small and large triangle. So for example, I'm using 4 and 6 because 4 and 6 are what's called corresponding sides. They're in the same place but different shapes. This is for the smaller triangle, and this is for the larger triangle. And then we have small over large again. We have 8 centimeters here, and this whole entire distance, we don't know it, but we do know that this one is called x, so we're going to call this 8 plus x. We cross multiply and solve and get x equals 4, which means that this value that's unknown to us, that QP, that's equal to 4. In the second question, it tells us that DE is parallel to BC, and it also tells us that EC is 4 and BD is half of AD. So what we're going to do is set up the same type of proportion here. We know that if BD is half of AD, then BD should be x, and AD is twice as big as that, so we'll call that 2x. In total, that's 3x. And then here on this side, we know that this piece is 4, EC is 4. We don't know AE, so we call this y. And then the whole entire thing is y plus 4. So we set up our proportion, and we start to cross multiply, but before we cross multiply, notice that 2x and 3x, they both have an x inside of them, right? That fraction has an x divided by x, so that cancels out, but that eliminates. And now what we have is y times 3 and 2 times y plus 4. We set up that proportion, we solve, and we get y is equal to 8. The question is asking what is the length of AC, and AC is y plus 4, so 8 plus 4 is 12. In this diagram, it's a right triangle. This is one of those puzzle questions. Find the values of D and E. Well, the first thing that I found out was since this angle is 64 and this angle is 90, 90 plus 64 is 154. Subtract that from 180, you get 26. So that missing piece there is part of the triangle that I'm going to trace out here. So again, I had 64, I had 90, and I added those two together and subtracted from 180 to get this 26. The next thing that we can do is, once we know that this angle is 26, we know that this angle is 95, so we can do the triangle sum theorem again. That 95 plus 26, what is that, 111? I think it's 121 actually. 121 subtracted from 180 is 59, so that's how we got that. Next we have this 59. Well, we know that the angle here, this angle, is a right angle, which means 90 minus 59 is equal to 31. A puzzle question in classic form. We were given a couple pieces of information and we were asked to find the others. Next, it gives us a exterior angle, and we are going to use the exterior angle theorem, which says the exterior angle is equal to the sum of the two non-adjacent interior angles. This exterior angle is equal to the sum, which is plus, of the two non-adjacent, these two angles, interior angles. Solve this equation. It's very straightforward. It's just an algebra question, and you're good at algebra. That's why you're in geometry. For question number 5, it tells us that it is an isosceles triangle, which means we have two base angles that are congruent. It also tells us that this top angle, this apex angle, is 3x. So if it is 3x, and these two angles are both 5x minus 28, we add those together and get 180. Solving that equation gives us 18.1538, and then multiplying 18.1538 times 5, and then subtracting it from 28, we get 12.769. That's our value of A. For question number 6, M is the centroid of DEF. As soon as it says centroid, we have one particular knowledge in mind, one particular piece of knowledge in mind. We know that this piece, A to M, is going to be half as big as this piece, M to F. In other words, MF is equal to AM times 2. That's what a centroid does. It splits each median into a 2-to-1 ratio. Solve that equation, you get x equals 19. Great. Moving on to the next page, again, you should try this before you check your answers. So pause the video, try it, and then come back and see if you're right. Here we're using a lot of trig functions, a lot of trigonometry, and you have to remember this SOHCAHTOA again, as I said in class. This is not given to you on your reference sheet, so please remember it. The situation here is that we're given an angle, we're given the opposite side, and we're asked to find the adjacent. If you're using opposite and adjacent, we're using TOA, which is tangent equals opposite over adjacent. Substitute in the numbers and make sure you get the correct answer. All right. One thing that students sometimes get incorrect is they don't use the correct setting on their calculator. Please make sure that when you're looking at the calculator, you go into the mode menu and go to where it says degrees. Press enter on degrees, which means now that your calculator is set in the correct way. So in other words, if I did tangent of 35, I should get 0.7002. If I didn't have it in degrees, I would get the wrong answer. I would get something that's completely different. Moving on to question 2. In question 2, looks like I can't really shift it over like that. In question 2, it tells us that tangent of A is equal to 0.4548. I'll shift it over anyway. If you get the tangent of an angle and you're asked to find the actual angle, we're going to use inverse tangent to find that. Tan A is equal to 0.4548. We're going to do tan -1 to both sides, which means A is equal to 24.4560. It asks us to the nearest degree, so we round that to 24. Question number 3, it gives us information about a rectangle, but wait, I thought this was all about triangles. Don't worry, it'll make sense in a second. The length of that diagonal is 15 inches. Oh, there's your triangle right there. And the length of the shorter side is 7. So what we're trying to do is find this angle, so we set up our equation, either S, C, or T, sine, cosine, or tangent, and we're given the opposite, which is here, and the hypotenuse, which is here, which means we're using sine. Solve it, and it says find to the nearest degree, so we're rounding to 28 degrees. For number 4, isosceles triangle DEF has base DF, which is 28 feet. If the base is 28 feet, that means that the altitude, which is drawn here, EG, is going to split that base into 2 equal portions. The base of an isosceles triangle is split in half, is bisected by an altitude. That's a thing that you need to know. All right, if D is equal to 42, here's your right triangle right here. We're given a right triangle that looks sort of like this. And what we do is use the good old trig formulas to try to figure this out. We're using tan because we are given the opposite, or we're trying to find the opposite rather, and we're given the adjacent. For question number 5, it's a ski slope question, and it was a little misleading maybe to say that this was 5018 feet and this is 5500 feet. That just means that we're finding the difference between these two numbers. That vertical distance is 482 feet, 5500 minus 5018. Now we're trying to find the length of the hill. That length of the hill is the hypotenuse of this right triangle, so that means this angle, this side, which is the opposite, and this side, which is the hypotenuse, are all in the calculation, so we're using opposite over hypotenuse, or sine. For number 6, we're given a right trapezoid. That right trapezoid has a base of 10 on the top, a base of 18 on the bottom, so we're using 2 different trig functions. We're using tan to get the value of x, which is this value. We're using tan because that's the opposite, and this is the adjacent. And then we're using cosine to find this side, because this is the hypotenuse, and this is the adjacent. Adjacent over hypotenuse means that we're using cosine. Once you get those 2 values, we're asked to find the area. There's 2 different ways to find the area. You can find the area of the rectangle, the area of the triangle, and add them together, or you could use this special trapezoid formula. This special trapezoid formula will always give you the area of the trapezoid, but you don't need to use it. All you need to do is use whatever is most comfortable to you. There were no units here, but if there were units, let's say if this was inches or centimeters or whatever, area, of course, would be in inches or centimeters squared, 2-dimensional shape. All right, we're moving on to the last page of Triangles Review. This was talking about similar triangles, isosceles triangles, triangle inequality theorem. Pause the video and see whether you can get these right. This first question talks about the triangle inequality, and it says that the sum of 2 sides must be greater than the third side. In other words, if you had a triangle and this side was 6, for example, and this side was 7, for example, the longest side that you could use to connect these 2 points and still make it a triangle, well, that has to be shorter than 13. Why? Because 7 plus 6 is 13, and if you tried to make a triangle out of a 7, 6, and a 13, it would be, here's your 6, here's your 7, and here's your 13. It would be just 2 lines that were overlapping each other. Anyway, this line, this side, must be smaller than 13. It also must be bigger than 1 because the distance between 7 and 6, that shorter side, if it's smaller than 1, it's not going to reach. It's not going to connect those two. So x must be greater than 1, but less than 13. Moving right along to question 2, it gives us the coordinates of these 3 vertices. We did a problem similar to this in class. We need to find all the distances in order to classify the triangle according to its sides. Remember, this distance formula is not given to you on the formula sheet, so you must remember it. It's x2 minus x1 squared plus y2 minus y1 squared, square rooted. We got the square root of 4 here, which is 2. The next side was square root of 20, which is a number that is a rational number. It goes on forever without repeating. And this is the distance of 4. All 3 of them are different, which means it is a scalene triangle. It turns out that this is also a right triangle, but it didn't ask us to say that. We're asked to classify the triangle according to its sides, which is either scalene or equilateral, if all 3 of these were the same length, or if 2 of them were the same length and the third was a different length, we would call that isosceles. For this question, it gives us angle D, which is 54 degrees, and it tells us that A is twice the measure of N, which means one of them is X, that's N, one of them is 2X, that's A. X plus 2x plus 54 is equal to 180 because those 3 angles are the 3 angles of a triangle. They add up to 180. So we solve to get x equals 42. So that means this angle is 42, this angle is 2 times 42, which is 84, and this angle is 54. The longest side is always across from the largest angle. So if this is the largest angle, that means DN is the longest side. I didn't draw this to scale because I didn't know the answers beforehand, before I started doing it, but it's always going to be that the longest side is across the triangle from the largest angle. I think I said that right. For question number 4, in right triangle RST, this altitude is drawn. I have 2 right triangles here. I'm going to highlight them now. All right, for this larger triangle, this blue triangle, you should see that it's got a hypotenuse of 10 plus x. That's across from the right angle. And it's got a short side of 12. So the hypotenuse and the leg is 10 plus x over 12. For this smaller right triangle, the hypotenuse of that triangle is 12, and the shorter side is x. Hypotenuse over leg, 12 over x. I'm able to use this because in a right triangle, any altitude is going to cut the right triangle into proportional smaller right triangles. So since they're proportional, I can use a proportion, which means I can cross multiply and solve. This is a quadratic. This is the most difficult type of equation that you'll see on the geometry regions, in my opinion. But a quadratic isn't really that bad because remember, you're looking for the numbers that add together to give you this middle term, and they multiply together to give you this last term. They add together to give you 10. They multiply together to give you negative 144. Long story short, that's negative 8 and positive 18. And when you solve these equations, you get x equals positive 8 and x equals negative 18. Well, you can't have a measurement that is negative. That wouldn't make any sense. You can't say, oh, I'm negative 18 feet tall. You could say that I'm positive 8 feet tall. I would be very tall, but you're allowed to say that. Last but not least, in question number 5, it's trying to get across to you that when you are looking at scale factor is the same between sides and between perimeters, but it's not the same for areas. For example, the scale factor between ABC and A prime, B prime, C prime, 5 over 10, that's this side, and this side, the 2 corresponding left-hand sides, the 2 corresponding bottoms, and the 2 corresponding hypotenuses. Hypotenuse? Who knows? 13 over 26, every one of these fractions give you 1/2. You could express the scale factor as 2 over 1, but if you're doing larger over smaller, every one of the problems has to be larger over smaller. I'm sticking to smaller over larger just for convenience sake. Find the perimeters of both triangles. That's 30 and 60. We added the 3 sides together. And then when we divided them, we found that the scale factor is the same. It should make sense to you that the scale factor between sides is going to be the same as the scale factor between perimeters, because perimeters is just sides added together. Areas is different, though, because I'm doing side times side. So this side times this side is going to be much bigger than the difference between the 2 perimeters, 30 versus 120 here. That scale factor, or the relationship between the areas, is 1/4. You can always find the relationship between areas by taking the scale factor and multiplying it by 2. All right, that was the video review for the triangles section. Good luck studying.